On page 4 of this activity, we talk about independent events. And I'm trying here to show you the difference between independent and mutually exclusive. Independent means that the probability of one doesn't change depending on whether the other event occurred or not. If I roll a die and then I roll a different die, those are independent events. If I get an even number the first time, it doesn't really change the probability of getting a certain outcome on the other die. Raining or Tuesday, those shouldn't have anything to do with each other. And if we go sampling in a bag of marbles or something like that, sampling with replacement, the result of the first pick will not change the result of the second pick. Right, we reach our hand in the bag, grab a marble, see what we get, put it back in the bag, mix it all up, try again, take another marble, pull it out. The probability of what we got on the first one shouldn't impact, or the outcome of the first draw shouldn't impact the outcome of the second draw. They're independent of each other. Now this is something to put in your notes, and maybe you'll understand it more intuitively later. Two events are independent if any one of the following statements are true. And I don't know if that's still page 176. That might be an outdated reference that I need to fix. But P of A given B is P of A. I sort of get how that would go with independent. It's like the probability that it's Tuesday given that it's raining is the same thing as the probability that it's Tuesday. It's like raining has nothing to do with it. A and B are symmetric, so the probability of B given A is the same as the probability of B. It's like this given A doesn't really do anything. And finally, the probability of A and B occurring is the probability of A times the probability of B. So these are three different things that should be true if two events are independent of each other. Are extroversion and left-handedness independent? Support your answer with one of the three criteria. So I calculated what is the probability of being an extrovert if you are left-handed, or given you are left-handed. Probability of being an extrovert if you're left-handed is 0.24. The probability of being extroverted outright is 0.39. So there is some type of relationship between left-handed and extrovert. It looks like once you're left-handed, you're less likely to be an extrovert. So that shows that extroversion and left-handedness are not independent. Okay, here's another example. The probability that a student gets an A is 0.40. The probability that a student is wearing a blue shirt is 0.20. Then you find out that the probability of getting an A and wearing a blue shirt is 0.08. And I'm going to show three different ways that all support that A and B are independent. Write the three conditions and show that each are met. So P of A given B. This is the formula from the previous page. So the P of A and B is 0.08 because that was given right here. And P of B is 0.20, that was given here. So when I divide them, I get 0.4, and that is P of A. So because P of A given B is P of A, that shows that that first condition is met. Then I go through the process and I do probability of B given A. And again, here's my formula. That's the same as P of B and A over P of A. Work that out, 0.08 over 0.40, and I get 0.2, which is P of B. So this is just a massive coincidence, but this is showing that A and B must be independent. Finally, is P of A times P of B the same as P of A and B? So if I take 0.40 times 0.20, I get 0.08. And that is what I said the probability of P of A and B was. And I think you'll be relieved to know that your likelihood of getting an A will not change depending on whether you're wearing a blue shirt or not. Okay, last little section here. In general, to prove that A and B are independent, you only need to show that one of those three criteria are met. So if one is met, all three of them will be met. They're all equivalent to each other. Draw a Venn diagram to represent the situation. So we knew that the probability of A was 0.40, and that means that the total for this entire circle is 0.40. But if there's 0.08 in the overlap, then that means there is 0.32 in that region right there. So I took 0.40 minus 0.08. Over here, we already knew that the whole probability for B was 0.20. So 0.20 minus 0.08 gives us 0.12. So these two regions together add up to 0.20. Are A and B mutually exclusive? No, because they overlap. There is something, it is possible to be wearing a blue shirt and get an A. These are two independent events, but they do overlap. If A and B are independent, is this the same as saying that A and B are mutually exclusive? A and B are independent and they are not mutually exclusive, so those are two different things. Finally, consecutive events. About 10% of people are left-handed. If you randomly select two people with replacement, what is the probability that both of them are left-handed? So this is another formula that I gave you, and the probability of A and B happening is the probability of A times the probability of B. 10% times 10% ends up giving me 1 out of 100, or 1%. So it's extremely unlikely that I would randomly select two students and that they're both left-handed.